Your grandfather's push mower had a cast iron carburetor, a metal fuel tank, and rubber seals made from Viton. It ran for 25 years on $5 oil changes and a fresh spark plug every spring. Your new mower has a plastic carburetor, a thin-wall polyethylene tank, and nitrile rubber seals that the fuel is actively dissolving right now, sitting in your garage. And the fuel that is doing it came out of the same pump at the same gas station you have used for years. This is not bad luck. This is not user error. This is a documented systemic failure built into every mass-market gas mower sold in America since 2007. 40% of gas mowers need major repairs before the third year. The manufacturers know this. The regulators know this. And the repair bill, which will cost you more than the mower is worth, is not a surprise to anyone except the person holding the dead mower. Today, we are going to open the hood on the small engine industry. We are going to name the specific parts that are failing, name the chemical process that is destroying them, name the companies that are profiting from the replacement cycle, and name the exact machines that refuse to participate in any of it. By the end of this, you will understand why your mower died, and you will know precisely what to do about it. Let us start with the business model, because the engineering did not fail by accident. In 2005, Congress enacted the Renewable Fuel Standard, administered by the EPA. Every gasoline pump in America began blending ethanol into the fuel supply. By around 2010, E10, 10% ethanol by volume, had become the dominant blend at the consumer level. Straight gasoline became increasingly difficult to find at standard pumps. That mandate was written for automobile engines. Small engines, lawnmowers, chainsaws, generators, pressure washers were not exempted. They were not redesigned. They were simply exposed. Now, here is where the corporate layer enters. Briggs & Stratton holds a significant share of the small engine market in America. In 2020, private equity firm KPS Capital Partners acquired Briggs out of Chapter 11 bankruptcy for approximately $550 million. Within 2 years, they cut 20% of the engineering and quality staff. Carburetor sourcing shifted from domestic suppliers to Chinese manufacturers. The carburetors themselves cost less to produce, savings of $2 to $5 per unit. On 5 million units a year, that math is attractive to a private equity firm managing a portfolio. It is catastrophic to the person buying the machine. They call this supply chain optimization. We call it the reason your mower will not start in year 3. The same story plays out at MTD, which makes machines sold under the Craftsman, Troy-Bilt, and Cub Cadet nameplates. Stanley Black & Decker completed the acquisition of MTD in December 2021 for approximately $1.6 billion for the remaining ownership stake. The carburetor and fuel system components are now shared across all of those brands. One failure mode, multiple brand names, 150 plus CPSC recalls on lawnmowers between 2014 and 2024. With fuel system failures accounting for 48% of them. Briggs & Stratton alone accounts for 25 of those fuel-related recalls. Their failure rate runs at double the industry average, according to Outdoor Power Equipment Institute data. They call it product complexity. We call it a class action lawsuit waiting to happen, but the business model is only half the problem. The engineering under the hood has been deliberately devalued. Let us get specific about what is failing and exactly how it fails. The carburetor is the primary kill point. On every mass-market mower built after 2007, the carburetor body is molded from plastic. The jets, the passages, the float bowl, plastic and cheap aluminum alloy. Inside that carburetor are rubber seals and diaphragms made from nitrile rubber. Nitrile is an economical material. It is also chemically vulnerable to ethanol at the concentrations present in E10 fuel. Before 2005, carburetor gaskets and seals were manufactured from Viton, a fluoroelastomer that is chemically resistant to ethanol, methanol, and every hydrocarbon blend the fuel industry can produce. Viton seals last the life of the engine. Nitrile seals and ethanol contact begin degrading within the first 100 to 200 hours of operation. On a residential mower running 30 to 40 hours per season, that is 3 to 5 years. The nitrile swells. The diaphragm loses its flex. The float valve starts to seat incorrectly. Fuel delivery becomes inconsistent. The mower surges, hunts, stalls under load, or floods. You spray some carburetor cleaner in it. It starts for one session. By the next weekend, it is dead again. Meanwhile, the main jet, a precision-drilled orifice typically measured in tenths of a millimeter, fills with varnish. Ethanol-blended fuel oxidizes faster than straight gasoline. The shelf life of E10 is typically cited at somewhere between 3 and 6 months, depending on storage conditions. Most homeowners store a partial can through winter. That fuel does not expire cleanly. It deposits a golden brown varnish that hardens inside the jet passages. The jet is now a smaller jet. The air-fuel mixture leans out. The engine overheats on the lean side and drops cylinder compression. Now you have a dead mower with a seized ring, and you paid $300 for it 2 years ago. The fuel lines are the second failure point. Pre-ethanol era fuel lines were rubber, typically fuel-grade rubber with fabric reinforcement, resistant to petroleum hydrocarbons. Post-2007 mass-market mowers use thin polyethylene tubing or non-resistant rubber hose. Ethanol is a solvent. It attacks the plasticizers in the line material, causing the line to harden, crack, and eventually leak. The leak is not always visible. Sometimes the line weeps internally, drawing air into the fuel supply. The carburetor starves intermittently. The diagnosis is confusing and labor-intensive. The repair requires replacing the entire fuel line set, which on most current mowers means routing hose through a fuel tank assembly that was not designed to be serviced. That brings us to the fuel tank. Older mowers use steel tanks. Post-2007 mass-market mowers use high-density polyethylene, HDPE, without an ethanol barrier layer. The tank walls are too thin and not coated on the interior surface. Ethanol infiltrates the plastic matrix over time. The seams at the bottom of the tank develop micro-cracks, phase separation residue. The white chalky deposit you see when you drain an old tank accumulates at the low points and feeds directly into the fuel line. The system poisons itself from the tank forward to the jet. The primer bulb on push mower carburetors is made of the same nitrile compound as the internal seals. It hardens in 2 to 3 years. It stops returning to shape after depression. The manual choke primer circuit fails. Cold starting becomes impossible without starting fluid, which itself damages the cylinder walls by washing the oil film off the bore. You are now accelerating piston ring wear to solve a fuel delivery problem that should not exist. Let us talk about what phase separation actually means inside your carburetor, because this is the mechanism most people do not understand. Ethanol is hygroscopic. It pulls water vapor from ambient air through any unsealed opening in the fuel system. E10 can hold several thousand parts per million of water in suspension during normal operation, significantly more than straight gasoline, which saturates at around 150 to 300 parts per million depending on temperature. When that E10 fuel sits in a mower tank for more than 30 days, as it does for every mower stored between October and April in this country, the ethanol absorbs moisture to the point of phase separation. The water and ethanol compound separates from the gasoline and sinks to the bottom of the tank as a distinct layer. That layer is what enters the carburetor first when you pull the rope in spring. It corrodes the zinc and aluminum jet passages. It swells whatever nitrile seals survived the previous season. It fires a cold start on a carburetor that is now internally compromised. By year 2, the carburetor is running compromised. By year 3, it is done. A replacement carburetor from an aftermarket supplier costs $20 to $50. An OEM carburetor from Briggs or Kohler runs $30 to $80. A dealer service call to diagnose, remove, rebuild, or replace that carburetor runs $200 to $400 once you add diagnostics at $100 an hour and 2 to 4 hours of labor. That service bill is the same cost as a brand new mower. So the consumer throws the mower away and buys another one. The manufacturer sells another unit. The cycle repeats. Consumer Reports documented that a consumer who buys one cheap gas mower today will buy 5 to 7 of them across their lifetime. That same consumer's grandfather bought one or two. Manufacturers recognize roughly $2 billion annually in replacement sales generated by this compressed failure cycle, according to Outdoor Power Equipment Institute market estimates. They call it consumer choice. We call it an engineered revenue stream. But the engineering is only half the crime. Wait until you see what happens when you try to fix it yourself. On a pre-2005 Briggs or Tecumseh engine, a carburetor swap requires a screwdriver and 30 minutes. The carburetors are standardized, interchangeable across multiple years and displacement classes, and documented in public service manuals that have not changed in 30 years. Parts are available at every small engine shop, every Ace Hardware, and online for less than $50. The repair is mechanical. The diagnosis is visual. The outcome is predictable. On a newer Briggs Quantum X or the EFI-equipped engines appearing on upper-tier models, proprietary jets and electronically controlled fuel circuits require dealer-level diagnostic tools to reset after any fuel system service. Replacing a fuel injector yourself triggers a fault condition that only a Briggs-authorized scan tool can clear. The scan tool is not available to the public. The dealer charges the diagnostic fee regardless of whether they perform the repair. Right-to-repair legislation covering digital electronics and agricultural equipment has passed in states including Massachusetts and Colorado, though as of 2024, legislation specifically covering small outdoor power equipment remains stalled at the federal level. John Deere's fight against independent repair is the preview. Farmers have already been forced into dealer-exclusive service agreements for tractor electronics that a journeyman mechanic could diagnose with an oscilloscope. Husqvarna and Briggs are copying the playbook with EFI small engines. The carburetor's simplicity, its greatest engineering virtue, is being replaced with electronics that serve the same purpose but cannot be serviced by the owner. The depreciation math completes the trap. A $300 push mower loses 30% of its value in the first year. By year 3, which is exactly when the carburetor fails, the mower is worth $50 on the used market. The repair bill exceeds the machine's value. The owner walks to a big box store. The manufacturer ships another unit assembled in Mexico or sourced from a Chinese contract manufacturer, equipped with the same plastic carburetor, the same nitrile seals, and the same thin-wall polyethylene tank. The cycle begins again. So if the dealer is a trap and the mass-market mower is designed to expire, does that mean you give up and push a handrail? No. It means you stop buying the disposal cycle and start buying the machines that were built to survive it. There are exactly 3 buying strategies that beat this system. Each one has mechanical receipts. The first is the Honda HRX 217. This is the machine that Consumer Reports has consistently ranked among the top gas mowers for reliability. The engine is Honda's GCV 200. The carburetor body is nickel alloy, a zinc aluminum casting with precision machine jet passages. The internal seals are Viton, not Nitrile. There is no plastic tank. Honda includes a 5-year residential warranty and supplies parts globally for 20+ years after production. Fuel lines are ethanol-resistant rubber. The deck is Nexite polymer, a high-impact resistant composite. This mower runs $300 more than a Craftsman equivalent at purchase, over a 14-year service life, which is the documented average for HRX series mowers with proper seasonal maintenance. The cost per year is approximately $50. The Craftsman equivalent, replaced every 3 years, costs approximately $120 per year and delivers inferior cut quality for its entire shortened service life. The only math that matters: Honda HRX 217 over 14 years costs $700. 4 Craftsman replacements over the same period cost $1,200 and 4 trips to the landfill. The second strategy is the pre-2007 used mower market. Any Briggs-powered mower built before 2007 carries the original cast aluminum carburetor with Viton gaskets. The float valves are brass. The fuel lines are oil-resistant rubber. These machines were built before the ethanol era and before the cost-cutting that followed. A clean, pre-owned Briggs-powered push mower from this era costs $100 to $300 on the used market. Carburetors, fuel lines, and ignition components are still in production and available at any small engine shop. A full carburetor rebuild kit for a pre-2007 Briggs costs $12. The machine can be maintained with a flathead screwdriver, a set of box wrenches, and a Saturday morning. Inspect the deck for rust perforation around the blade hub and at the discharge chute mounting points. Pull the air filter and check the carburetor throat for varnish deposits. Light staining is acceptable. Heavy buildup means it has been sitting on bad fuel and the float valve will need service. Check the oil level and condition. Black oil that smells of gasoline indicates ring wear and blow-by. Walk away from that unit. Clear oil with normal color and appropriate level means the engine has been maintained. Buy that mower. The third strategy is the battery electric transition. The Ego LM2135 running on a 56-volt lithium battery and a brushless motor has no carburetor, no fuel lines, no ethanol exposure, no spark plug, no primer bulb, and no oil. The only mechanical wear items are the blade and the battery. The battery is a replacement component at end of service life, currently retailing in the range of $200 to $300. Documented service life on the Ego platform is 10+ years. The mower itself costs $600 new. Total 10-year cost of ownership is competitive once you factor in the absence of fuel costs, carburetor rebuilds, and dealer diagnostics. No fuel, no carburetor rebuilds, no dealer diagnostics. The repairability is straightforward. Brushless motors and lithium batteries are serviced with standard hand tools and components available through the manufacturer and third-party suppliers. Commercial used equipment is also worth targeting. A used gravelly or Ferris commercial walk-behind from the used market at around $1,000 carries a Kawasaki or Kohler commercial engine built to 500+ hour service intervals with cast aluminum blocks, commercial spec carburation, and fuel system components rated for fuel blends up to E15 by the engine manufacturer. These machines were built for daily use by landscaping crews. They are overbuilt for residential applications and effectively indestructible under normal homeowner use cycles. When buying any commercial used unit, check the blade hub bearing for play, inspect the self-propelled drive cable for fraying, and verify the engine oil fill is the correct capacity. Overfilling a small engine destroys the crankcase breather and sends oil into the air filter, which looks like a head gasket failure and is not. Here is the mechanic's final verdict. The ethanol in your gas is not going away. E15 is already approved and spreading to more pumps. The plastic carburetor in your mass-market mower was not designed to survive it. The nitrile seals will swell. The jets will varnish. The fuel lines will crack. The manufacturer already priced your replacement unit into their revenue forecast. Stop buying the disposable cycle. Start buying the machine that was built to last, or the machine old enough that it predates the system designed to kill it. Use ethanol-free fuel if it is available in your area and your budget allows it. It costs roughly 50 cents more per gallon. It extends the service life of any fuel system that is not already compromised. Drain the tank and run the carburetor dry before every winter storage. That single step eliminates 90% of the spring varnish failures. Use a fuel stabilizer rated for ethanol blended fuel if you must store fuel in the tank. But the better investment is the right machine to begin with. Buy the Honda or buy a machine old enough that the ethanol era never touched its design. Either way, buy something you can fix with your own hands in your own driveway with parts that do not require a dealer login to access. That is not a truck. That is not a subscription. That is a mower. It should start on the first pull and cut grass for 20 years. Anything less is a product they sold you, not a tool they built for you.